Hi, in this video we're taking a look at 2018 Maths Ordinary Level Paper 2. This is question 3 and it's a probability question. So we have the following situation. We have to find a number of different arrangements that can be made using all the letters of the word rainbow. So the best thing to think about is that first of all we're going to be selecting one letter out of 7. Then we're going to be selecting one letter out of 6. So let's multiply that, and 1 out of 5, 1 out of 4, 1 out of 3, 1 out of 2, and then 1 out of 1 letters. In other words, 7 factorial. And if you calculate that on your calculator, we're getting 5040. Second part of this problem asks us to find the number of different 3-letter arrangements that can be made using the letters of the word rainbow, and each letter is used once. So for the first letter we're going to be selecting 1 out of 7, for the second letter we're going to be selecting 1 out of 6, and for the last letter we're going to be selecting 1 out of 5 letters. If we calculate this out, we're going to be left with 210 different 3-letter arrangements. In the next question we are told about a game called Rainbow, which uses unbiased circular spinner. The spinner has 7 sectors: red, orange, yellow, green, blue, indigo and violet, as shown in the diagram. The table below shows the angle of each sector, and it also shows the cash prize the player wins when the spinner stops in that sector. So let's take a look. The first thing is to complete the probability column. So the probability for each of the areas is calculated by taking the angle and dividing it by 360, like in the example. 45 by 360 is 1/8. So filling these areas in, for red we're going to do 72 divided by 360, which is 1/5. Orange is 1/12. For green we have a quarter, 1/6 for blue, 1/20 for indigo, and finally 1/8 again for violet. The next thing is to find the expected value for the prize winning for a player who plays rainbow. So expected value is for a given game is calculated by taking a sum of probability of some outcome multiplied by price of that outcome. So let's take let's call it capital X. So in our case the expected value for the winnings will be equal to probability of getting a winning out of a red, which is 1/5, multiplied by 20, plus probability of winning out of orange, 1/12, multiplied by 60, which is the number of winnings, and then we'll continue like that for all the other possibilities of winning. So 1/8 by 24, plus 1/4 by 8, plus 1/6 by 42, plus 1/20 by 90, and finally plus 1/8 by 48. So when we calculate that, we're going to end up with the following expression. That's 4 plus 5 plus 3 plus 2 plus 7 plus 4.5 and plus 6. When you sum it all up, we're going to get 31.50 as an expected value for winning. So this is the end of this problem, and it's a good place to stop.